To start us off, we're going to talk about this article released by Duncan at JitX. JitX is the correct...
JitX is, yeah.
JitX.
As far as, I mean, he hasn't corrected me if I'm mispronouncing it this entire time.
Okay, JitX. Duncan wrote this article. Duncan is the CEO at JitX. He wrote an article testing generative AI for circuit board design, and he goes through a bunch of different, really almost the full stack of what you would want to do if you were trying to do any task related to circuit boards with design. He tries to parse data sheets. He tries to find parts. He asks questions. So
he's pretty thorough.
Super thorough. What was your hot take reading this article? How did you react to it?
I think it's the second comment now on the Hacker News article, or the first line of it, that sums it up pretty well for me. It's like, this feels like an excellent demonstration of the limitation of zero-shot LLMs, which, yeah, I feel for sure. It's one of those things of like, these data sheets are so large, and the structure really matters. There's so many tables and whatnot that they actually do reasonably well for really structured questions like, hey, can you give me a pin map of this? But even then, you as an engineer, you're like, ooh, I don't really trust this thing.
Right.
And you need to go back and do it, like check it yourself.
Right. There's a huge question of trust, right? Like even if it outputs like something that is structured correctly all the time, can you actually trust it?
Yep.
I got a little bit of a different take reading this article. I was like, wow, this is going to happen.
Oh,
that's
absolutely.
how I felt. I was super motivated. I had toyed around with some of this stuff before reading this article and even ran some local models. It felt to me like the reason why some of these things failed is just nobody has fine-tuned on it, or nobody has like really concentrated on the data set. But it seems like what Duncan said is, for asking EE questions, it's pretty good.
Yes.
And
yeah.
I think
most of the EEs I know already do. Like typically, that
yeah.
you know, it's insanely valuable at the very least double check of like, here's roughly what I'm thinking. Like high level, you know the internet. Like what else might there be, or how does this roughly work? It's a fantastic first point there.
That's right, and it knows the textbooks too.
Yes.
So especially if your problem is phrased in a kind of smart way. Although he calls this section asking stupid questions. But his question was fairly specific. His question was, let's see, what is the delay per unit length of a trace on a circuit board?
Yep.
I mean, it's
a
not,
better answer than I would have come up with.
Yeah. I mean, the answer takes into account a lot of things, not just the length of the trace, but also what layer it's on.
Dielectric material.
Dielectric constant.
The geometry of the trace obviously affects things as well, and not just obviously propagation delay, but also signal integrity and whatnot. It does definitely get there and mentions those other aspects as well.
It's a thorough answer.
Yeah.
It's a thorough answer. But that's something you might be able to pull from a textbook, right?
It's something you could probably lift from a textbook, and it would be really hard to find.
Yeah.
I think actually, so I definitely don't mean to sound like a bummer about it, because you're saying like we've got a different perspective. Mate, we're both sitting here because we got the perspective that this is totally going to happen.
Right.
And so it's a case of when and how. And so kind of more my thinking behind it is, just like humans, you got to ask the right questions. Working in Germany for a little bit, you kind of feel like they like to build a lot of processes, and they like to use humans as the gears in those processes. Well, we're really bad gears. We're not very deterministic, and we're pretty unreliable in a lot of ways, but we can be really creative and bring in a lot of context. And I think I look at LLMs in really the same way, and generally AI. And so I see this article as like what are the right questions for AI and generative AI as well. Do I want a one-shot, like, hey, come up with a PCB for me and like you do it all right from scratch. Here's my top level requirements. Even if you give it all the requirements, like obviously I'm not going to trust it.
Right.
But if you can break down that problem and say something more along those lines of maybe less the like, what's the propagation delay in this case, or more of a what like, how would I go about finding the requirements for this design?
Right.
How would I go about finding what validation and conformance I need to do, or compliance testing I need to do? And then you can kind of block together these now deterministic chunks, but you use this as almost your search algorithm.
Yeah. Yeah, I think that's a big part of it is how do you take something that's all over the place, like
Yep.
not reliable, needle in a haystack, like,
Yep.
and how do you break it into chunks that will be reliable? And I think the reason why Duncan wrote this and not like LTM or somebody at a different company, it has to do part with he can like actually ask them to do something. Like he generates JITX code. Does
Yep.
JITX code have a name? Does the language
Stanza is their
Stanza.
language.
Okay,
Yep.
right. So he actually generates Stanza. So theoretically, something you could use with it. That gets down to, you can serialize it into something deterministic. Like it can actually go to something. In LLM explaining how a circuit works in text, that's going to be different every time. But explaining how it works in code, that can be consistent. How you represent it in AutoPile, how you represent it in JITX or TS circuit, that can be fairly deterministic,
Yeah.
I think.
I think it can be fairly deterministic, but also once you've got a reasonable block of, so let's talk about synthesizing Python code with an LLM, for example, because it's pretty analogous, but it's been trained on a heck of a lot of it compared
Yes,
to
a lot of data.
Stanza, Addo, or TypeScript. I guess you've got plenty of TypeScript because
There's
you're
a lot
just
of TypeScript, but not circuits. So
Yeah.
it always feels like it's kind of hallucinating
Yep.
just a little bit.
Yeah, just a smidge. But let's take the requests module in Python. If you ask it to go query some API endpoint, perhaps the most prolific task you get it to do, it does it right every time. But it doesn't try rewrite the request module, right?
That's right.
It knows what to pull in. And it's sort of the standing on the shoulders of giants type thing that I actually really see this electronics as code approach is going to allow. It means that you can modularize the intelligence behind your design and then get some intelligent, or in my case, semi-intelligent being to actually, I was going to say the AI, but it's much smarter than I am. You can get it to basically reconstitute those blocks in a way that, it's pretty good. If you only need it to write like 10 lines of code, those 10 lines are going to be right. You just need to try and minimize how much it needs to express.
Yeah,
so that's really the game.
Absolutely. So Duncan touches on a couple other things here. Finding parts.
Yep.
This is, I think that this is something that a lot of people are going to try to do. A lot of people are already trying to do it.
Have you tried it yet?
Finding parts with AI, I've definitely put stuff into ChatGPT.
Yep.
I've gotten good results for extremely simple stuff that I basically already knew how to do.
Yep.
But it's been helpful sometimes.
Yep. So one thing that I found amazing with Copilot, which is GPT 3.5 Turbo, I think, GitHub's Copilot. If I start typing in Addo code and start saying module regulator, blah, 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 and start having a few specs there, it will start recommending, here's an LM2 something or another.
Oh, nice.
And it will actually go configure that device because it's read the data sheet.
Nice.
And so with the right context, I've actually seen it do this. It might not be the best part by any means, but it can definitely do it, and it kind of wants to.
Yeah, that's really interesting. Like, and I don't know if maybe people are doing this. I don't think people are doing this for coding yet necessarily, but sometimes I import a module and it doesn't have the context inside of that module, but that's got to be something they build on a Copilot eventually, where like for example, in TypeScript, you have type definitions all over.
Yep.
And half the time I'm programming, Copilot recommends the wrong things because it just can't read the type definitions.
Yep.
But if it pulled in that context, it'd be amazing. Probably, so yeah, I mean, that could be huge if you could pull in the context of the data sheet for every component in the code you're working on.
Yep,
absolutely. It would probably predict everything. And Duncan actually talks about this. Like, he gives a data sheet. His third section is on parsing data sheets, and it's perfectly able to do pinouts.
Yep.
So ideally, if you're doing electronics as code, you do not have to copy a pinout, hopefully.
No, absolutely not. I jumped straight to the application note. So I was doing the other day for the Bikey Wagon.
Yep.
I was configuring or designing a regulator module that I wanted to later configure. And I just side by side had up the data sheet's application note and my code and just chapter by chapter transposing it. And it will transpose it for you.
That's
if you dump
awesome.
in that context, you start typing and it'll just kind of go ahead, which is incredible because they've literally given you recipe, step-by-step instructions.
That's
on
right.
exactly what you need to do.
Right.
And it can definitely port that out and sort of transpose it.
Yeah, and I think this is a big thing that I think Duncan was talking about in this article is LLMs do really well where the context kind of exists somewhere.
Yep.
Like data sheets have reference designs, and if you have those like in a format the LLM can understand, if it's able to help you with it, then it works. But sometimes LLMs fail because if reference designs, like the schematic you might find on SparkFun or something, it might not explain every decision. It's much different than a reference design.
Yeah.
Or a data sheet. You don't know why it's like that. And so for larger applications, like some of the ones Duncan was trying to do at the end, like a full circuit design, it kind of can't do it because it never learned. It never had like the notes from the engineer inside the engineer's head to know why the circuit is built like that.
Yeah,
And so,
in the same section, he was also talking about how schematics today, say you have a resistor and a capacitor as an RC filter. Well, an LLM today typically doesn't have the vision capabilities to pass that out and decide, oh, this subsection of the schematic, this little blob here, is totally an RC filter with some constants that are useful behind it, and therefore do the maths and sort of transpose out that data. And as an engineer, you sort of train to pattern match trivially. Now, I don't think it'll be that long before someone, and I know a group, the diode.dev folks, are actually doing this, working towards this with schematics to sort of transpose them and extrapolate all this data back out into Addo code. But once AI can extract this data back out and operate in its home domain of text or let's say really context-rich text, then it's really off to the game for sure.
For sure. I'm super interested in that. And I'm also curious how the ecosystem works when people begin to parse data sheets. Like, I don't know how the business models work or what happened. Like, what I wish existed today was somebody who took every PDF data sheet out there and outputted this really easy context for me to input, for me to load in when I'm doing design. But I don't know how that'll work. There's not really a database of data sheets today that's kind of freely accessible. So I would imagine if somebody did this, it wouldn't be a freely accessible context thing. Maybe it would be like almost like a language server that when you're working, it can kind of query for data sheet context. That would be pretty cool.
Yeah, I mean, look, we already have our open source component server, which it just does resistors, caps, like basic components, inductors, and it has a few FETs in there. And you can query sort of spec basis.
Oh, nice.
It's fine. I mean, the API is open and so is the source code for it. Like, go play for sure for anyone who's interested. But like way further and more advanced than that, there's the e-data sheets, I think they're called, which is a project basically to define a schema, a common JSON-based schema for datasheet data in a way that we can actually all access exactly as you're describing. I don't know how much they've populated their databases so far, but at least a common language is a great first step.
Oh, absolutely. I don't even know what would be cool for any of these electronics as code companies to be part of the language that they put in there. So there's a lot of visual elements of a data sheet.
Yes.
There's you have your reference diagram, which is usually a schematic. You have landing patterns, lots of stuff, and not really a good format to put any of them in.
No. And actually, this is a really interesting question because both with code for people and for LLMs, how do you want to describe a landing pattern?
Yeah.
I mean, like really tangibly, how do you want to do it?
Absolutely. Like you could describe it based on its constraints.
Yes.
There's this much width. You could describe it based on the pattern.
Yep. You could describe it based on, like, there are these thermal constraints as well, like sort of more abstract constraints that we think of.
Absolutely. And then all the standard stuff is easy, I guess. If it's a BGA, whatever, you can say the pitch and stuff like that.
Yeah. If you're just going to...
But for weird landing patterns, it's very difficult.
Yeah, extremely so, particularly when you're incorporating other constraints like RF or thermals directly into whether it's the landing pattern or the layout of your reference design.
Yep.
You don't want to say, oh, layer 2 needs this. It's like, no, is layer 2 the other side of the board? And why do you need to use the back of the board?
Right,
All of a sudden. I believe, I don't think it's in this article, but recently JetX did also release some pretty fantastic auto routing that, as far as I understand it, is based somehow in LLMs based on this type of constraints.
Really?
Yes.
That's so cool.
It's really awesome.
Yeah. auto routing is another one of those things where you're going to, I cannot imagine a world where you don't go to a specialized system or at least a specialized AI for auto routing. Like, that's not going to be output by ChatGPT.
No.
You know, people are like, oh, ChatGPT will kind of take over and incorporate the functionality of more and more startups, and then you won't need those startups or whatever. But auto routing is that's going to be a dedicated AI. Yeah, that's going to be a dedicated.
I actually just this morning I got an email. You familiar with Quilter?
Yeah, Quilter. Yeah, absolutely.
So I just got an email from them this morning saying that they've just released their new revision, which is 27 times faster and 10 times more likely to actually complete the job that you asked of it.
Whoa.
Which 6 months ago, I struggled with a little bit on the time basis and the completion basis, and the team there was great in helping me get through those. But 10 times faster means that 27 times faster means that I can kind of like go self-serve as well, because I'm willing to sit there and have a bit of a play with it too.
Absolutely.
So everything's, it's accelerating quickly.
Wow, that's so cool. We should definitely
get Sergey
do something.
On too.
Yeah, Sergey on, and also just like kind of compare some of these tools. I don't know if anybody's run a comparison, but
we've spent this whole time talking about other tools. We've done ourselves a disservice. But
So the last thing on this article that I made a note on was, my take on it was, he didn't really do static analysis against the against what the AI created, right? And something I see a lot of potential in is it outputs something, it's the wrong part, but you try it out. You put that into code, you try it out, and then your static analysis tells you that it's wrong. And then the AI can correct itself. So it seems like to me that would fix maybe 30% of the problems he brought up. Sometimes I'm not sure if it tried again, if it would ever be able to get it. Sometimes it was recommending, I think, wrong values or weird configurations that just made no sense. Mm-hmm. So still way off, but I do think that that's one potential area that could be improved.
Well, we talked about the trust of things as well. And so that's that. I mean, you're just hitting it exactly on the head. If you have a really reliable, robust set of static analysis, validation, simulations, all sorts, and all of a sudden you don't really care as much if the AI gets something wrong,
right?
Because you're going to find out, and that's really the imperative here, is that when you go manufacture the thing, at least in production, that it definitely works.
Yeah. And even with I'm going to get the name of this wrong, but I think there's a tool like Wakwi, something like that, and it emulates a lot of chips like an ESP and an Arduino online.
Okay.
And you can put in like a full design.
Really?
I think and it runs the code. It'll like blink an LED or whatever you want to do. I didn't look at their more complex designs, but if you can run that level of emulation,
is it running it like as a spice model, or?
I think I have not looked into how it works. I don't know. I just know that they're emulating an Arduino pretty closely, at least. And I think it's in WebAssembly too. So
cool.
Very crazy project. Maybe a future topic
episode
to dive into. Yes. I think that's probably a good place to wrap it up. Any final thoughts or?
No, look, I really enjoyed chatting to you this morning. Thank you very much, Seve.
Excellent. All right, perfect. Thank you, Matt. And that's Electronics Dev.